Today's guest is Vicky Neale, a mathematician at the University of Oxford. She's just written a book about why people should study mathematics at university. So, of course, I wanted to find out why Vicky studied mathematics at university. So, the beginning is always a good place to start. Where are you from? Where were you born?
I was born in a place that we moved away from when I was 6 months old. So I was born in Worcester, but I know nothing about Worcester. I grew up just outside Winchester in the south of England. So a little village near a small city.
So when you go to Worcester or Worcester comes up in conversation, do you feel any warmth or attachment to it because you were born there? Or is it just like complete coldness?
It's mostly coldness. I have been to Worcester a couple of times to go and do maths with young people. And I was curious to go and see, having been born there, but I know nothing about the place. I'm sure it's a lovely place. I've just not spent very much time there.
Did you go and track down the hospital you were born in or anything like that?
I spent some time trying to work out whether the university building that I was working in was somehow, or they bulldozed the hospital and replaced it. I never really got to the bottom of that. I wasn't so excited, to be honest, to know exactly where I was born. I was more interested in finding somewhere nice to have lunch. Seemed like more of a priority.
Tell me then what you were like as a youngster. Would I have seen little girl Vicky and said, well, she's going to be a mathematician?
I don't think you would have been surprised that I now do maths. I think my friends from secondary school are not surprised that I'm now doing maths because I really liked maths when I was at school. But I certainly had no idea that I might go on to do the kind of things that I've done professionally. That wasn't remotely on my radar. I don't think I understood when I was at secondary school that people had jobs as university lecturers. I think if I'd stopped and thought about it, I'd have worked out that somebody must do the teaching in universities, but I didn't really stop and think about it. So I definitely didn't imagine that I would find myself doing this kind of thing. I had no kind of concrete ideas of what I wanted to do beyond maths was fun.
What did you want to do when you grew up then? What would the answer have been when the adults said, and what do you want to be when you grow up, Vicky?
I'm still waiting to grow up. I think growing up might be overrated. I still don't know what I want to do when I grow up. My answer as a secondary school student was, I don't know, maybe something to do with maths. And then people would say, oh, do you mean like a maths teacher in school? As though that was the only thing that you might do if you studied maths further. I don't know. And being a maths teacher in school is a terrific thing to do, but it didn't seem like the thing that I wanted to do. It didn't feel like the right fit for me. So I was rather vague about the whole thing. I think I just sort of hoped that something would turn up, that maths was a sufficiently useful thing to study that I would find an interesting job somehow.
Well, what were your other hobbies and interests when you were a girl? Were they sort of maths adjacent or were there other things you were into?
No, I spent a lot of time playing music. I learned the piano and the oboe when I was at school, and I spent quite a lot of my secondary school time playing in orchestras. I loved playing in orchestras. So I didn't do that much maths outside of school. I had a few opportunities come up through Royal Institution masterclasses when I was 13 or 14, and then UK Maths Trust things starting when I was about 16, which was fantastic. But I also spent a lot of time sitting in the middle of an orchestra playing the oboe.
What about sort of family and friends, parents and things like that? Were you surrounded by mathematics and mathematical people? Or what did your parents do, for example?
My parents are both mathematical, but wouldn't necessarily describe themselves as mathematicians, I guess. My mum was a secondary school teacher and taught various things, including maths for a while, but would be modest about her mathematical capabilities, probably overly modest, given that she was a secondary school maths teacher. My dad's background is in electronic engineering, so he did lots of maths as part of that, but very much maths as an engineer rather than maths as maths. So I think the conversations when I was growing up, maths was part of the conversation, but it wasn't, let's discuss maths over the dinner table per se. It was more just an everyday part of life that these things might be interesting things to discuss, along with physics and IT and embroidery and all sorts of other things.
When you look back at your maths education at school, the people I speak to, I get such mixed responses about how they look back at it. Some people, it was this wonderful, warm experience at school. Other people, it was like this dreadful, terribly taught thing that they kind of persevered with despite it. How would you describe your school mathematical education?
I think I was lucky in the teachers that I had who were always very supportive. I enjoyed the maths that I did at school. I think I was probably the annoying kid who kept wanting to be fed more. I sort of might finish some problems and can I have some more maths to do, or can I have something more challenging to think about? I'm not very good when I get bored. I like having interesting things to think about. And some of the maths in school was great because I found it really stimulating. And sometimes it seemed a bit, I don't know, I've done some questions like this. I know how to do this. I don't really want to do lots more. So feeding me enough maths to do was sometimes a challenge for my teachers. I was probably a nuisance to them. I discovered some books in the local library on maths, sort of Ian Stewart books and those kind of things, which I found really helpful for showing me where maths could go beyond what we were doing at school. So I guess the work at school was inevitably very focused on the school curriculum and GCSEs and A-levels and so on. And that was great. I enjoyed that. But it was also really exciting to see where else the subject could go and blow my mind a bit with trying to understand concepts that I really didn't understand.
Were you then taking those concepts back to the classroom and bamboozling your teachers, or?
I hope not, because I think I might have been quite annoying if I did. I don't remember doing that too much, but maybe a bit.
You sound as though you were very self-motivated.
Yes, I suppose so. Nobody has ever said, Vicky, you have to sit down and do this maths now. I've always been very happy to get on with it. And I guess it's one of the things I like about my job now is that I have quite a lot of flexibility to do things that I find interesting and just get on and do them. I don't have somebody saying, oh, the next job you have to do is this, or those kind of things. So yeah, I guess that fits with being the kind of teenager who was happy to get on with doing the work and also doing whatever else needed to be doing.
Besides music and mathematics, what might I have found you doing? Would it be kind of the nerdy stuff like Rubik's Cubes and puzzles and games, or would I have found you playing hockey or watching TV? What else were you into?
Yeah, you would definitely not have found me playing hockey, possibly even when that's what I was supposed to have been doing at school. I was never deeply into hockey. I used to go swimming sometimes. That was quite good for clearing the head, and lots of craft things. I like doing craft things and still like doing craft things.
So as high school started drawing to a close and you had to start making actual decisions about university, what was the thinking and what were the decisions that were made?
Yeah, it was never a very difficult decision. I remember having a difficult decision when I was about 15 and applying for sixth form college, because I went to my local comprehensive school, and in Winchester they stop at age 16. They don't have a sixth form. So I had to go to sixth form college for my A-levels. And I remember it being completely clear that I wanted to do maths and further maths. And I figured I should do physics because it seemed like that's what you should do. And what I kind of wanted to do was French and German. But I sort of had this idea that doing maths and further maths and physics and chemistry was a thing. I'd somehow got that impression. And I remember having a conversation with my maths teacher who was very wise and very helpful and said, if you want to do French and German, do those. So I loved doing the languages alongside that. And I enjoyed the physics A-level, but there was really never any doubt at all in my mind, I think, that I would be applying to do maths at university. I didn't know where, but for me, it was a very easy decision. I know some people find it very hard to choose, and there are lots of things that they're interested in, and I didn't find it a difficult decision.
At that point, at kind of sixth form, this is, the very end of high school, you're choosing to do mathematics at university. Is this because you've just got this insatiable love of mathematics, or at this point, are you starting to see a career path?
Yeah, honestly, it was just that I loved doing maths. That was the only rationale. I really enjoyed the problem-solving aspects, and I really enjoyed that I didn't get bored thinking about maths, that they were concepts I grappled with. It wasn't that I found it all easy. I sought out challenges to think about, and the UK Maths Trust Olympiad questions, for example, I spent quite a bit of time as a sixth former failing to solve Olympiad problems, and right. I guess I solved just enough of them to keep me motivated to want to keep solving them, but I also spent quite a lot of time not solving them, and I really enjoyed that challenge and the idea of doing more of that sort of, not lots of routine questions, but questions that get you thinking and you have to find creative solutions and how might I go about doing this and so on. I was really keen for that kind of thing. I had no career plans at all. I just sort of got the impression that maths degrees opened lots of doors, and I sort of figured I'd worry about it later on. I was told that I should go and get some careers advice, but the careers advice was limited. And I think everybody recognised that actually I was just wanted to do maths, and that was fine. Nobody tried to talk me out of it.
Did you compete in any of those math Olympiads as a school student?
Yeah, so I took part in the UK ones, and I did just about well enough to be invited to a few events, sort of training camps and things, and then didn't make it any further, which was fine. I wasn't very interested in the competition part of the competitions. I loved the fact that they gave me interesting maths to think about. And I loved that when I got to go to a couple of these events, I met other young people who were also super excited about maths, and we could talk about maths, but also talk about not maths. I mean, it's not like we talked about maths the whole time, but just interacting with other people who didn't think I was a bit odd for enjoying maths. So I loved all of those things about doing the competitions. The actual competitive part didn't interest me very much. I wasn't very motivated by that.
Oh, I won't ask you about medals or anything like that then.
No, don't.
Tell me, where did you go to university then as an undergraduate?
I was an undergraduate in Cambridge.
You were getting pretty good marks then at school.
Yeah, I guess so.
What was it like going to Cambridge then, going from, school level mathematics to big league?
Yeah, I loved it because there was lots of interesting maths to think about, and there were lots of interesting people around to chat about maths and other things. So it was definitely not clear to me going through the last couple of years of school that I would make it to Cambridge. Not clear at all. I still remember the results day and trying to believe what the piece of paper said. So yeah, I did not take that for granted at all, but I loved it. It was really exciting to have lots of time for mathematics and not having to do other things that I didn't enjoy quite so much.
Was the demands difficult though? I hear from a lot of people that go to Cambridge that suddenly think, God, I've got to work so hard. And it's like a real change of gears. Did you not find that?
I think I'd already been used to working quite hard. One of the things I really liked about the sixth form college was that we had quite a bit of unstructured, free time in between lessons, and I could crack on and work on some maths. And I enjoyed working on Olympiad problems and the problems that I had to do for the Cambridge kind of paper. I just got on and worked on those in a pretty self-motivated kind of way. So I guess I was already used to spending a long period of time sitting and failing to solve a maths problem. So when I got to Cambridge, it felt quite natural to spend lots of time sitting and failing to solve maths problems because I'd done that already. And I did solve some of them, but I was already, I guess, quite used to grappling with that. It was quite intimidating being in an environment where the buildings are however many hundreds of years old and you keep being reminded that Isaac Newton was a student here and that kind of thing. So there was quite a lot of imposter type feelings and should I really be here?
Yeah.
But I enjoyed the mathematics a lot.
And also, obviously, you've probably gone from being mathematically a pretty big fish to just being another person who's pretty good at mathematics. Like you're surrounded by the cream of the crop. How did you find that adjustment?
That's true. But again, because I'd been involved in these training camps, I'd already been a very small fish.
Yeah.
So I just loved the fact that there were other people around who were keen to discuss mathematics and so on. Not that my entire life revolves around mathematics, but
I don't think I've ever spoken to someone who sounds like they were so prepared for university and found the transition so natural.
I think, yeah, looking back, it's a bit of a surprise. And and it was demanding and the workload is intense, but I guess I was sort of up for that challenge.
And then how was your undergraduate sort of years at Cambridge? How did things evolve for you there?
Yeah, I mean, like everybody, ups and downs, but I kept enjoying the mathematics. I found some interesting ways to do mathematical things during the summer. Not the first year. I got a job and earned some money doing something not quite so exciting.
Well, you got to tell us what that is.
I worked for a teddy bear company.
Like what, doing what?
Yeah, I spent a bit of time doing admin for them and sorting out some spreadsheets, and I spent a bit of time packing teddy bears in cardboard boxes, which was cool, just not very mathematical.
At what point did it become clear that, you were going to go further than just an undergraduate? Like you weren't going to go off to the city and become a stockbroker?
I must have made a decision about that at some point. I don't think going to the city and becoming a stockbroker was ever really something that I thought about doing. I don't really see myself in that environment. I was applying for internships for the vacation between my second year and third year, and I was offered a sort of position in a sort of financial sector kind of thing, but I was also lucky enough to have the opportunity to do a research project, and somebody was going to pay me to stay in Cambridge and do maths over the summer, so I decided to do that instead. And then I spent the next couple of summers working for Enrich, which is a maths education project, and really enjoyed that, really enjoyed getting more insight into kind of maths education and how people learn mathematics and how we can support students with learning mathematics. So it just felt really natural to think, well, actually, I want to stay on and do the fourth year, the master's year. And yes, I think I would like to do a PhD and keep doing some more maths. I didn't feel like I was ready to stop learning mathematics.
How does life change when you go from undergrad to master's to a PhD? Like, how does life change and how does the mathematics change?
For me, going from undergraduate to master's didn't feel like very much of a change because the format of the course was quite similar. It was a taught master's. It's a 1 year, the final year of an M-Math. So it was sort of more of the same, except that I was specialising a lot more and had chance to try to choose courses. And that was quite interesting, just finding out more about which bits of maths I particularly enjoyed and realising that some bits of maths were not my natural habitat. Going to do a PhD then was quite different because it's not so much structured time and you don't have lots of deadlines each week. It's, I guess, more like having a job. Somebody gives you some money and you have to do some work. But there was a lot more sitting in my office, staring out of the window, doodling with ideas, trying to figure out what I was supposed to be doing and trying to read research papers and understand what they were going on about and so on. So it was quite a different experience from somebody presenting a lecture course where they've organised the ideas very carefully and this stuff's pretty well understood and it's been around for a long time. So people have worked through and found a really nice way of approaching the ideas and so on. So the PhD kind of apprenticeship in research, I guess, felt quite different working pattern, and I could sort of go to work in the morning and sit in my office and then go home in the evening, which is quite different from being a student and just working in my room whenever I felt like it.
You talk about some areas of mathematics not feeling like your natural habitat, and obviously other ones did. Can you tell me about the bits you liked and didn't like and why you think that's the case? Like, is it just the wiring of your individual brain? Was it just the personalities of the teachers you had? How does that unfold?
I don't know. This is something I've wondered, having now taught lots of undergraduates and sort of watched lots of undergraduates going through their journeys of finding what excites them mathematically. And I think it was partly just which questions I instinctively was interested in being able to answer. I don't mean like problems on a problem sheet, but I guess a piece of mathematics has been developed to answer a question. The reason somebody has proved a theorem or come up with a new definition or organised a piece of work is that they're trying to answer a question. And some questions I found just instinctively, I thought, gosh, that's a really interesting question. I'd like to know the answer, and others not so much. I think I also found there was a bit of trying to find what level of abstraction suited me. So some maths is very, very concrete and some maths is very, very abstract and lots of maths is somewhere in the middle. And some bits I thought, actually, I just don't instinctively think as abstractly as that, or this is too applied for me. So I think it's partly about, individual differences and also which bits that I enjoyed enough that I wanted to put the work in to try to understand them. So inevitably, I was more inclined to work hard on things where I thought, actually, I'd really like to know the answer to this. I'd really like to understand what this is about. This is really cool.
A lot of mathematicians, when I've spoken to them about this stage in their career, I've been surprised by the number of them who've talked about how they made a choice based on groups of students they liked or a supervisor they liked and things like that, rather than the mathematics itself. It sounds like your decision-making, though, was based very much on the work, the content.
I think to a large extent it was, and the people around me, some of them were specialising in the same things as me and some of them were going in different directions and so on. So I didn't feel like that was a big pull. Of course, when you have a really fantastic lecturer, then the work feels more understandable and maybe you have a clearer sense of why it's exciting and you can be inspired by somebody. So I'm sure that was a factor, but I guess some of the people who taught me who were inspiring were in bits of maths that I didn't then go on to pursue. And there were also some people who were not quite so inspiring.
What was your area of specialisation? What was your PhD in?
My PhD is in additive number theory. So I was interested in number theory and combinatorics. So I told my mum I was doing a PhD in adding up whole numbers. And she said, Vicky, you did that when you were 5. And I said, yes, but this is different, adding up whole numbers. I guess one of the things that I like about the area that I was working in was that it pulled together strands from different bits of maths. So the things that I ended up using to prove a theorem in my PhD thesis were not necessarily things I thought I would be using when I started. I quite like that thing of different bits of maths coming together. I think we often think of maths as being separate boxes of pure and applied, or this is number theory and this is analysis and this is geometry and this is differential equations or something. But of course, actually, it's really interconnected. And I ended up using ideas that I'd first met in a nominally applied course as a second year undergraduate that turned out to be helpful for grappling with a problem about whole numbers, which I thought was quite cool. So that flavour appealed to me somehow.
Do you look back at your PhD thesis fondly? Did you discover something interesting?
Not very. The theorem that I proved is of, I would say, limited interest. In a way, the point wasn't so much to prove the theorem as to see whether the techniques could be used to solve a problem of that type. So what I was doing was taking work, kind of ideas that Hardy and Littlewood from the first half of the 20th century had developed, but then combining them with work by my supervisor, Ben Green, and his collaborator, Terry Tao, to try to apply those ideas in a sort of different context. So in a way, the result itself was not so exciting. It was more being able to apply those techniques, combining the older and the newer to make it work out. That was, I think, the thing that I found interesting. I mean, it's kind of cool to have proved a theorem. I'm glad to have proved a theorem.
Yeah. Also, Hardy, Littlewood, Green and Tao, you're dropping... I'm no mathematician, and even I know they're big names.
Yeah, they're quite good names to drop, aren't they?
Yeah. So at any point during the PhD, did you have that feeling that, I'm not going to do it, it's going nowhere? Or did you steer the course pretty well on that spectrum between despair and cruising easily? Where did you fall?
I think I spent a lot of my PhD feeling very doubtful that I would ever get a PhD. I remember having conversations with friends in other subjects, and I think in some subjects, it's just a very different kind of experience. You can sort of start out with, this is the question I'm going to tackle, and you do a literature review, and then you think deeply and you write and you think and you write and you rewrite. But you sort of know that you're going to come up with a thesis. It might be a better thesis or a less good thesis, but you will have a thesis. Whereas the kind of work that I was doing, it wasn't clear, at least to me, that I was going to prove this theorem. And if you don't prove a theorem, you can't write a thesis saying, well, I tried very hard and I didn't prove a theorem. That doesn't get you a PhD thesis. So I worked on more than one problem during the course of my PhD. There was one that I kept going back to, which was the one that I ended up solving, and it had different facets to it. So when I'd spent 3 months being stuck on one direction, I could switch to a different aspect and try something different. And occasionally I'd try a different problem altogether. But it wasn't clear to me until really quite close to the end whether I was going to solve a problem and exactly what the thesis would be about, which I found a bit unsettling. Maybe some people are very calm about these things. I found it a bit worrying. Am I ever going to finish this thing? But got there in the end. And having a supervisor helps with that.
Do you remember a moment? Do you remember a breakthrough, or walking across a bridge and suddenly it all came to you, or lying in bed or something where you realised, I've done it, I've proven it?
There wasn't one moment like that. There were different bits of the problem that I had to solve. So it would be a case of getting one bit done and then moving on to another and so on. So it felt to me more like chipping away at a problem. I don't know. I sort of had this mental image of a very hard stone ball, and every now and then I'd manage to chip a tiny little piece off it. And just occasionally I'd have chipped enough pieces off that a really big lump would come off and sort of something would open up a bit more. But it wasn't one kind of eureka moment or anything like that.
You end up with Michelangelo's David at the end.
If only. And then I'd go and talk to my supervisor and I'd say, well, this is where I've got to. And we chat about it, and he'd suggest some directions for attack. And I go and sit and doodle at my desk and stare out of the window some more. I think a lot of my better ideas came when I was doing the washing up or going for a walk, or those kind of activities where your brain is a little bit occupied with something else, but not too occupied, I think can be good for having good ideas.
So you've got your PhD. Congratulations.
Thank you.
Now what?
Yeah, I wondered that too. And I spent, as lots of people do, lots of time coming towards the end of my PhD, applying for lots of jobs and not getting them. And I was applying for postdoc type jobs, so the next step in the academic pathway. And I'm not sure I was totally sure that that was the right fit for me, but it seemed like the thing that you should do. And I applied for lots of jobs and got rejected for lots of jobs, and you sort of think, well, I'm not sure about this. And then completely randomly, I spotted an advert from one of the colleges in Cambridge who were looking for somebody to do a few hours a week of teaching for their undergraduates and to be what's called a director of studies, so like their personal academic advisor to their maths students. And I thought, well, that would be a really cool thing to do. It's just a one-year appointment. They said you could do this alongside finishing your PhD. And I thought, well, that would be a really interesting thing to do alongside the fourth year of my PhD. It would help the finances a bit, but also I'd really enjoyed the undergraduate teaching that I'd done already during my PhD. They said that it would be suitable for a PhD student or also a postdoc. And I thought, well, somebody with more experience is going to apply for this. I'm not going to get this job, but I might as well apply for the practice, and somehow got the job. And that was fantastic for me, actually. So I was at Murray Edwards College for a year as the director of studies and working with the maths students there, and really enjoyed that, really liked the environment I was in, really liked being able to be there as a mentor, advisor, support, teacher for these students. And that then turned into a full-time job for a couple more years. So I was at Murray Edwards doing lots of teaching alongside other bits and pieces. And then the other bits and pieces sort of evolved some more. So I was working on a maths education project then for a couple of years alongside teaching at Murray Edwards. So I worked on something then called the Cambridge Maths Education Project, then became Undergrad Maths. And I did that for a couple of years, designing resources for A-level maths students and teachers, so 16, 17, 18-year-olds and their teachers, alongside teaching undergraduates. And I didn't see any of that coming. There was no plan to do any of that as I came to the end of my PhD. But when I looked back over my PhD, there were lots of things I'd enjoyed. And I felt that the things that I'd enjoyed most and that I'd done most effectively have been about communicating mathematics and teaching and sharing mathematical ideas with other people, more than sitting by myself in an office trying to prove a theorem, which is a fantastic thing to do, but wasn't my thing to do, maybe.
So what do you do now? How do we get to where you are now?
Yeah, so 6 years ago, that's a long time now, I moved to Oxford, and I have this great job title. I'm the Whitehead Lecturer at the Mathematical Institute, and I am a Supernumerary Fellow at Balliol College.
All right. I'm going to try to say that. Supernumerary Fellow?
Very good.
What does that mean?
Somebody once corrected it. They thought it was a typo when they were writing my name down for something and put Supernumeracy Fellow and thought it was about maths, which I loved.
All right.
It means that I'm just some random type of fellow. So yeah, I have this great job title that tells you nothing about what I do. But what I do in practice is I teach undergraduates and I do maths outreach, public engagement with maths. And the role in college, I'm a tutor for students at Balliol. So I work with the maths undergraduates and teach them, and I'm also available for them to come and chat to me individually about whatever. And then I lecture in the department and do other interesting mathematical projects, either by myself or working in collaboration with colleagues.
I want to talk to you more about sort of outreach and books and a few other things you've done, because that's obviously what you're known for and you're a bit of a superstar in that area. But before I flatter you by talking about that, let me ask you this. Where does someone who does what you do fall in the math pecking order amongst all the bigwigs in the coffee room, you know, the people who are doing like, you know, pure research and things like that? Do they respect and love the teachers, or is there kind of like this sniffiness? Or I always wonder about that.
I guess within the Oxford Maths Department, for example, different people have different roles, and there are some people who are just doing research. I'm really unusual in having a teaching focused role that doesn't involve research. Most people do both. And I guess inevitably some people enjoy teaching more and feel that that's a more important part of their role. And for other people, it's a sort of taking them away from things that they would like to be doing, or quite a lot of work or whatever. But I really like finding other colleagues who are interested in teaching and discussing those ideas with them and so on. So no, I'm not remotely as important as the people who are kind of proving spectacular theorems and changing the mathematical world. And I'm immensely privileged to be in a department like Oxford where I have colleagues like that. Teenage me watched the Simon Singh Horizon program about Fermat's last theorem when that came out a long time ago. And I always recommend that to people if they haven't seen it. I think it's on iPlayer, so you can watch it at least within the UK for free, and it's fantastic.
Yeah.
And teenage me would not have begun to comprehend that I would now work in the Andrew Wiles building, and that Andrew Wiles, who put that final very large brick in the wall of Fermat's last theorem, is a colleague, and that's surreal. One of my colleagues, Roger Penrose, has recently won the Nobel Prize. I don't really know what I'm doing in a department with these people, but I feel very lucky.
I mean, you're obviously a very accomplished mathematician, but do you ever feel an envy of those people who are going to, have their names on things forever and who inspired you when you were younger? Do you ever wish that was your job? Like, solving the Riemann hypothesis?
No, not remotely. I have no aspirations to my name being on anything long term. If I have a little bit of an impact on the students that I work with, that for me would be amazing. I'm not concerned about there being a theorem named after me or anything like that. I have no aspirations in that direction.
I want to ask about your latest book because I'm very curious about some of the things in it. But before I do, I want to ask you about mathematical craft.
Yes, mathematical craft.
Tell me about mathematical craft. What does that mean?
I just like doing craft and I like doing maths. So for me, it was really natural to try to combine the two. So every now and then I sort of have an idea of, maybe I could explore this piece of mathematics through this particular technique, and a craft that, I might have been sitting on the sofa knitting, watching the TV in the evening anyway, and I might as well knit something mathematical rather than making a jumper or something.
Can you give me an example of one or two of the things you've done?
Yeah, so one thing that I did was make some bracelets to explore the distribution of the prime numbers. Someone gave me a book. It's called something like Bead Crochet for Mathematicians. I'm not sure that's exactly the name, but something like that. And I'd never heard of bead crochet before, but I just looked at this and thought, this is really cool. And so you make a torus. In the jewellery community, they call them bracelets. So you make this sort of donut thing.
The jewellery community.
You make a kind of bracelet out of beads. So it's a sort of cylindrical tube that you can join up at the ends. And the book has some fantastic designs in it, which I found really inspiring. But then I sort of got me thinking, actually, I could use this to illustrate some particular feature about prime numbers, which was something that I've been discussing with school students for a while and so on. And that was really fun. And then you make something that's visually attractive and people are kind of curious and, what's going on there? And
I'm looking at a picture of it now. It sort of looks like, like you say, like a torus, like a donut made of all these tiny little beads. And the one I'm looking at here, most of the beads are blue, and there's this just random scattering of gold beads amongst the blue beads, and presumably those gold beads represent the distribution of the primes.
Exactly, yeah. So the gold beads are the primes in the sea of blue non-primes. And it does look kind of random, and yet there's this potential structure to it. So it's a way of visualizing something about mathematics, but also I think there's something tangible about when you make it as a craft object. I've knitted scarves, I've stitched greetings cards as well, and there's something about it being a physical object that somebody can pick up and look at, or it's a different way of engaging, I guess. And for me, it's a natural thing to do because I like knitting and crochet and stitching and so on. If I were a more technically minded person, I would be making clever video visualizations, I guess, but that's not me.
Well, maybe we can have a chat about that later.
I'm always up for collaborating.
Super. Now, you've written a couple of books. I'm not going to ask you much about your first book about prime numbers because I want to ask you about that for some Numberphile videos another day. But I do want to ask you about your most recent book, Why Study Mathematics by Vicky Neale.
That's the one.
Before we talk about the question of why study mathematics, let me ask you, why is there a polar bear on the cover?
Yeah, the publishers told me that I should tell people they'd get that question answered if they read the book. So there are sort of two reasons for having a polar bear on the front. And one is important message about the power of mathematics to address climate change. And the other is a slightly less serious illustration of some mathematical ideas, which features a polar bear somewhere else in the book. And I'm not going to say any more about that right now, if that's okay.
Oh, okay. No spoilers here. You have to buy the book if you want to find out why there's this huge polar bear's head peering out of the cover at the potential readers.
It's a great polar bear.
What is the point of this book? Why study mathematics? What's the book trying to achieve?
The book's designed for students thinking about options at degree level to help them think a bit more about, is a maths degree right for me? Is that what I want to do? Which maths degree might I do, given that there are lots and lots of maths degrees out there? Where might a maths degree lead me later in life? And also then hopefully for teachers and parents of those students who might be supporting students making decisions. I guess trying to, in a way, fill in the gaps that prospectuses leave. University prospectuses have lots of great information, and now we're doing it all online. There are videos and lots of information out there. And I guess this book is trying to pull together some of the things that you might not find in the prospectus about what kind of things might you cover in a maths degree, and is that the good choice for you?
So it's quite like a focused book. It's not just for the person in the street it's not like one of these popularization math books that someone like me would pick up just to see some cool stories. This is got a real utility, this book.
Yeah, it has a definite focus, and it's part of a series. The idea came from the publishers, the London Publishing Partnership, who have this vision for a series. So there's also Why Study History and Why Study Geography out there, and there are more on the way, I gather. So it is designed for a particular audience, but I'm hoping that it will be of interest a little bit more broadly. So I can imagine, for example, that a teacher who is a terrific maths teacher, having done perhaps physics or engineering degree or something, might find it useful to be able to dip into the book and have a sense of some of the mathematics things in a maths degree that they can then share with students, for example. So some of the book is quite practical about how does teaching work in a maths degree, and how does assessment work, and how do you choose between different degrees, and what kind of careers are there. But there's also, I've tried to give people a taste of some of the topics that you might come across in a maths degree. And actually that was an interesting challenge, because brilliantly, there are lots and lots of different maths degrees in the UK. I think this is a really good thing, because it means that people could choose a course that suits them. But trying to work out things that lots of maths degrees have in common was quite interesting. So exploring some of that. So I've tried to pick out a few different themes and give an idea of where they might go on to. So differential equations tying into modelling disease, which at the point when I started writing the book seemed like an important topic. And then we had a global pandemic and it became daily national news, which was kind of striking. But also links between linear algebra and JPEG image compression, for example, drawing out different ideas. Ramsey theory, which is a sort of branch of graph theory that links up with ideas in networks and so on. So trying to pick out some themes, maybe things that people might have seen before, but hopefully also lots that people wouldn't have come across before.
Is this kind of a bit like a Lonely Planet, though? Like, are you saying, well, if you go to the University of Nottingham, you'll get this, and if you go to Cambridge, you'll get this? Like, are you making that granular a comparison, or is it more sort of broad brush overview and you're not sort of naming names?
It's a bit more broad brush. I'm not naming names, not least because courses change over time, and I don't want the book to be out of date too soon. But when I was choosing a university, it wasn't apparent to me what a variety there was. One of the phrases that gets used sometimes is that you can think of maths degrees as being more or less theory-based and more or less practice-based. So some are more theoretical and academic, and some are more concretely tied to how you might use those ideas in an industrial context, for example. And in reality, most degrees are somewhere on this spectrum. It's not that they're one or the other. But those kind of things were not at all clear to me when I was applying for university. And I think it can be hard to pick that out. So what I'm hoping is that by reading the book, people will then be able to look at the UCAS website, to look at individual university websites and prospectus, and sort of have some questions in mind to ask themselves, I guess, of, what are the things that I should be thinking about when I'm looking at these maths degrees that will help me decide, is this a good fit for me?
Vicky, you mentioned not wanting the book to be out of date. And you also mentioned briefly the pandemic that everyone in the world is living through. Is your book pandemic proof? If you're writing about what it's like to go to university and be taught, and it seems that how we're being taught at university is changing at the moment, like how's that an issue for you? It's
something that I was really aware of because I was putting the finishing touches to the book in the spring at a point when I was teaching all of my students exclusively online. And so I'm really conscious that our practices are changing. I think at the point when we hopefully have the vaccines, we have more flexibility about how we do these things. What I'm hoping is that we are going to hang on to the things that we have learnt that we can do through these situations that actually are fantastic for teaching and learning, and regain some of the things that we've been missing. And actually, with my own teaching this term, working with my students, we've been doing a bit of mixing and matching. So I've been making lecture videos because I would otherwise have been lecturing to a room of 200 students, and that's clearly not possible at the moment. But for the small group teaching, where I'm doing tutorials and classes with perhaps 2 or 3 students, or perhaps 10 or 12 students, we can do that socially distanced with face coverings and so on in a room together. And I'm hoping that as we move on through the next, say, 3 to 5 years, that we will be looking at how we go about doing our teaching at university level and thinking, well, what's the most effective thing for students learning? What is the best for students? How can we help students in the most effective way? And maybe some of that is online. I think there are some advantages to lecture videos, but also having the face-to-face. So, yeah, it will be interesting to see how that evolves over the coming months and years.
You mentioned that this book is part of a series for, why study history, et cetera, et cetera. Did any part of you feel like, you're at a sort of a friendly competition, or as an advocate for mathematics against those other subjects? Like you're having to make the case, come and study mathematics instead of history? Is that part of this?
I don't want to think of myself as being in competition. I said earlier, I'm not really a competitive person. I think my main priority, and I have this thought in mind when I meet students at open days, for example, is that I want students to be making an informed choice, and I want students to pursue a path that feels right for them, knowing everything that they need to. And I absolutely think it's terrific that there are lots of people who go and study history and geography and all of the other things, because as a society, we need people with lots of different skills. I also think that maths is a really terrific thing to study, and that we probably need more maths graduates for society. So if I can help people to have the information that they need to make that informed decision about, is this right for me? Could I see myself doing this for the next 3 years or something? That's my goal for the book.
It sounds like, you've had an education and a career that's had its usual share of ups and downs and challenges and things like that. But generally, it sounds like it's been fairly smooth sailing, and it's also been a bit of a fait accompli that you would be a mathematician. Does that make you the best possible person or the worst possible person to be counselling us about why study mathematics?
I think that's a really fair question, and definitely 17-year-old me wasn't making a difficult decision about whether to study maths. I was trying to work out where to study maths and will I get in and what can I do to prepare and all of those kind of things. But for me, should I do maths or something else was not a difficult decision. But I have since then worked with quite a lot of students and have had the privilege of being alongside students as they've been going through their mathematical journeys and arriving as undergraduates, maybe with particular career plans, maybe with no career plans at all, and seeing how they've then found their mathematical feet, decided what kind of job they want to go on to next, or do they want to go do further study or something. So I hope that I have been able to learn from them, possibly more than they've learned from me. And also talking to friends and colleagues in other universities and getting ideas and experiences from people teaching on these other different kinds of courses has really informed how I've written the book, because my own personal teaching experience has only been in a couple of universities, but I've hopefully drawn on expertise from others.
I mean, you've written a whole book on it with answers to the question, why study mathematics? And I encourage people to go and have a look. But perhaps to finish our talk today, could you give me one good reason why someone should study mathematics? If someone's out there and they're at that crossroads and maybe mathematics is for them, maybe it's not, and they're having to make that key decision. And I know everyone's different and has unique circumstances, but could you perhaps give us one reason why they should study mathematics?
Well, one reason out of the whole book is, as you say, an interesting challenge. I think maybe the short answer is the flexibility that mathematics can give you. If you are interested in mathematics, you can find your corner of mathematics, the kind of mathematics that you find most interesting, and it gives you flexibility about what you go on and do next. And maybe your priority is to find a career that allows you to support your family and have the lifestyle that you want. Maybe your priority is to have an intellectually challenging career. Maybe your priority is to have a career where you can have a really positive impact on wider society. And for all of those kind of routes, mathematics is potentially good. You can study mathematics to help people. You can study mathematics to make lots of money. You can study mathematics to have a lifestyle that gives you a good work-life balance. So flexibility, I think, is the key. If you enjoy maths, go for it.
You can find out more about Vicky, her work, and of course her books by checking out the links in the notes from today's episode. Numberphile is supported by the Mathematical Sciences Research Institute. Again, there's a link in the notes. I'm Brady Harron, and you've been listening to the Numberphile podcast.